Click the bell icon to get latest videos from Ekeeda.
Hello students, we have studied numericals based on ROC but in Laplace transform. Means what? We are going to find out, we have calculated the region where the function is stable. Now here we are going to do a reverse process. The today's topic is a numerical based on ROC but in inverse Laplace transform. Here the function was already given and the ROC value is also given. We have to find out the stability or the locations of particular pole where the graph will be shifted, or you can say according to ROC what will be the changes we have to make in output of function. So this is all about the introduction. Now we'll move on to problem number 1. So problem number 1. Find the inverse Laplace transform of function is x of s equals to 4 upon s plus 2 s plus 4, and if the ROC is minus 2 is greater than the real part of s is greater than minus 4, which means this is our two-sided ROC and these two are the right hand sided and left hand sided. Now here is real part of s is less than minus 4, which means we have a left hand sided ROC, and here we have ROC real part of s is greater than minus 2, which means here we have a right handed sided ROC. Now we know that if your ROC is moving or is a left hand sided, then we will always replace all the u of t by minus u of minus t. If we have a ROC which is a right hand sided, then u of t will be there. I'll repeat. Whenever we have right-handed side ROC, we will always write unit step value, that is u of t. But if we have a left-hand sided ROC, then we will always replace all the u of t by minus of u of minus t. So be careful while solving this ROC value. It is not difficult to find out the partial fraction value of x of s, but next onward we are going to find out inverse Laplace transform, but on the basis of this given ROC. So first of all, just go through we'll solve the question. Now here we have x of s is 4 upon s plus 2 s plus 4. Here we have a simple poles and multiple poles. Now we know that if we have a simple pole and multiple pole, then there is a simplest way. No need to find out the differentiation value or no need to substitute s equals to 0. We are going to substitute only s equals to minus 2 and s equal to minus 4. Now look at here. In question we have x of s equals to 4 upon s plus 2 and s plus 4. So first of all we'll find out this variable. The variable is total depends on number of poles. Here we have 2 poles, then of course we'll use 2 variables. It is not compulsory to write s plus 2 in the denominator of a. You can write s plus 4 also. Now we'll move on to next. Here we have a simple poles, so it is not necessary to find out a derivative of this b function, or else it is not necessary to place s equals to 0 in any value to find out variable a or b, value of a and b. So what is important here, what we are going to do here, we are going to substitute s plus 2 equal to 0 to find out value of a. So what will be the value of s? To find out value of a, we'll simply substitute s plus 2 equal to 0. So s will be minus 2. And to find out value of b, what we are going to do, s plus 4 you will equate with the 0. So you will get s equals to minus 4. So first of all, I'm going to write this is my equation number 1. Now I will multiply this left hand side denominator with on right hand side. First of all I will multiply it with a and then I will multiply it with b. Look at here. If s plus 2 and s plus 4 is multiplied with a, then s plus 2 s plus 4 will get cancelled, s plus 4 will be there, and here the s plus 4 will get cancelled, s plus 2 will be there. Now simply, as I told you, if we want to calculate value of a, then substitute or equate s plus 2, a denominator value of a, with 0. Equate this denominator value of a equal to 0. What you will get? S plus 2 equal to 0, which means s equals to minus 2. So simply, if we want to find out any variable value, then always equate the denominator value equal to 0 and find out s value, and use the same s value to find out or to substitute s value in equation. So here the s value is minus 2 So I'm putting s equals to minus 2 in equation number 2. What we'll get? On the left hand side we have simply 4, but here if we substitute s equals to minus 2, then this s is replaced by minus 2 plus 2 becomes 0, so the whole product becomes 0. Now look at here we have s plus 4, so if we substitute minus 2 over here, so 4 minus 2 becomes 2, so what we have? A 2a. Now if we shift this 2 on the left hand side, so the 4 will be divided by 2, so answer is 2. So therefore my a value is 2. Now similarly I will substitute s equals to minus 4 to get the value of b. How I have got s equals to minus 4? As I told you, equate this whole bracket equal to 0. So s plus 4 equal to 0, so s equals to minus 4 is the result. S equals to minus 4, I'm going to substitute in equation number 2. What we will get? This s is replaced by minus 4, plus 4 minus 4 will get cancelled. So the whole a product becomes 0. But here if this s is replaced by minus 4, then what will get? Minus 4 plus 2, answer is minus 2. And if we shift this minus 2 on left hand side, then 4 is divided by minus 2, result is minus 2. Now substitute a value and b value in our equation number 1. So after substituting a b value in equation number 1, what we have got? X of s is 2 upon s plus 2, and in place of b we have minus 2. So this part will become minus 2 upon s plus 4. Now the next step is we have to find out value of x of t, or you can see we are going to apply inverse Laplace transform to find out value of x of t, but that totally depends on the ROC. In question there are 3 ROCs are given. The first one is two-sided, second one is left-hand sided, and third one is right-hand sided. So first of all I'll write the first ROC value, which was, this was our first ROC. Now our first ROC was minus 2 is greater than, real part of s is greater than minus 4. I am rearranging this value. Now look at here. Basically our poles are minus 2 and minus 4. So first of all on S plane I will place all the poles value. Basically minus 2 is the higher pole, whereas minus 4 is the lowest pole. So this is our minus 2, which is a higher pole, and this one is the minus 4, which is the lowest pole. Now here ROCs exist between minus 4 and minus 2. Look at here. Here the ROC is, in this case, ROC is greater than minus 4, which means for minus 4 the ROC is right handed sided. So according to properties, if the ROC is right handed sided, then all the poles or all the ROCs will be there on the right side of rightmost pole. This was the right sided pole, or you can say this was the pole. So your ROC is available on the right hand side of this pole. Now look at here. In this case, a real part of s is less than minus 2, which means this ROC is left-handed sided. Now, if the ROC is left-handed sided, then we will always mark ROC on the left side of that pole. So this is the pole where the ROC is left-handed. Now, as I told you, the ROC of this minus 2 is left-handed, whereas ROC of plus 4 is right-handed, which means this is a two-sided ROC. So how to draw it? So this is our ROC. Now what is important? We have to find out a Laplace inverse of this function on the basis of this ROC. How to do? I'll show you. Look at here. Here this pole ROC is left hand sided. So as I told you, if the ROC is left handed sided, then all the unit steps are replaced by minus of u of minus t. And if we have a right handed sided ROC, then we are going to place only u of t. So first of all, I'll write down the inverse Laplace transform of this function. Let's say this is our equation number 3. So applying inverse Laplace transform on equation number 3, what we'll get? I'm going to apply inverse Laplace transform on this equation, but our total inverse Laplace transform is completely based on the ROC number 1. Here the ROC is this minus 4 having a right handed side ROC, whereas this minus 2 pole is having left hand sided ROC. So first of all, inverse Laplace transform x of s is x of t. But now here we have a plus 2 poles, or you can say a pole which is having a left handed side ROC. First of all, I'll write down the constant value which is 2. This was the constant value. Next, this s is delayed or shifted by plus 2 value, which means here we have to use a frequency shifting property. So according to that, this t value which is placed in the exponential term is multiplied by the opposite sign of 2. So opposite sign, here we have plus 2, so I'm going to multiply it with the minus e to the power 2. Now what will be there? A 1 by s is remaining. Now 1 by s inverse Laplace transform, 1 by s is unit step, but as this function or as this pole is left hand sided, so we have to replace that u of t by minus u of minus t. Now we'll move on to next. Here we have minus sign and the 2 is the constant. This s plus 4 pole gives or shows a right handed sided ROC, which means the u of t is there as it is. So s, first of all, this s is shifted by 4. So according to frequency shifting property, this t is replaced by opposite value of 4. The 4 opposite value is minus 4. And as I told you, the ROC is right handed sided, so I'm going to write only unit step. This is the inverse Laplace transform of this function for the first ROC. Now we'll do the same thing for next 2 ROCs also. Look at here. In case of two-sided ROC, look at the movement of ROC first. As from this equation, you can say that the minus 4 ROC for minus 4 pole is right handed sided. That's why I have multiplied this whole function by whole part by u of t. Whereas in this case, this minus 2, the ROC for this minus 2 is left handed sided. That's why I have multiplied it by minus of u of minus t. So please be care of this one. Take care of this one. Just remember this whole concept now, and I'm going to use the same concept for next 2 ROCs also. So let's move on to next ROC. Now the second ROC. This ROC is less than minus 4. Less than minus 4 means what? This ROC is the left hand sided ROC. Now whenever if the ROC is left hand sided ROC, then all the poles exist on the right hand side of that pole also having the ROC which is a left handed sided. Now we'll find out first of all pole 0 plot. Now we have 2 poles. First one is s equals to minus 2, another one is s equals to minus 4. I'll plot the locations first. This one is a minus 2, this one is minus 4. Now here the real part of s is less than minus 4, which means this pole or the ROC of this function is a left hand sided. Left hand sided means what? According to properties of ROC that we have studied in properties of ROC video, if the function ROC is left handed sided, then the ROC always plotted on the left hand side of leftmost pole. Now here the leftmost pole is minus 4, so your ROC is available on left side. And one more thing is the ROC for all the poles which is on right hand side is also a left sided, which means here we have 2 poles, and according to ROC, our ROC is left hand sided, which means these 2 poles will also follow the same ROC. then the ROC is on left hand side of this -4 pole. So this is our ROC, which is on left hand side of -4 or leftmost pole. Now how to write the equation? As I told you, if your ROC is left hand sided, then all the unit steps replaced by -u of -t. So first of all, I will find out the inverse Laplace transform of equation number 1. This was the equation number 1. What we will get? This x of s is replaced by x of t, or you can say a Laplace transform of inverse Laplace of x of s is x of t. Now this 2 is a constant, so I'll write down over here. Now we know that s plus 2 inverse Laplace transform of 1 upon s plus 2 is e to the power. This t is multiplied by opposite value of 2. So we'll multiply it by -2, and 1 by s is unit step. But look at here, as the ROC is left-handed sided, then all the poles having a similar ROC, or all the poles will follow the same ROC, which means this unit step is replaced by -u of -t. Then we'll find out ROC for this. So here we have already -2 as a constant. S plus 4, here the s is delayed, which means we have to take help of frequency shifting property, and we'll multiply opposite value of -4 with the t. So we'll multiply it by -4, and here also the unit step is replaced by u of -t, -u of -t. So this minus sign will become plus, and this u of t is now written as it is. And this is the inverse Laplace transform of this function when the ROC is left hand sided. Now the third ROC is right hand sided ROC. So we'll find out the value or a graph as well as the x of t value for the right handed sided ROC. Now look at here, our x of s was 2 upon s plus 2 minus 2 upon s minus 4. Now here the ROC is greater than -2, which means this ROC is the right hand sided ROC or a causal ROC. Now according to properties, if the function ROC is right handed sided, which means we are going to plot ROC on the right hand side of rightmost pole. So the rightmost pole is -2, so your ROC is available on right hand side of this rightmost pole. So our ROC is available on right hand side of rightmost pole. Our rightmost pole is -2, so your ROC is on right hand side. So this is the ROC. Here all the function will produce a finite value. I'll apply inverse Laplace transform on equation number 1. This was our equation number 1, but the inverse Laplace transform is completely based on this ROC. Now the inverse Laplace transform of x of s is x of t. This 2 I'll write down as it is. Now s plus 2, which gives us e to the power -2t, as I told you, is as the s is delayed by 2 or s is shifted by 2, then multiply opposite sign value with the t. So opposite value is -2, and as the ROC is right handed sided, which means all the poles will follow the same ROC. So here I'm going to write 1 by s value is nothing but u of t minus, we'll move on to next 2, the s plus 4 we have 1 upon s plus 4, which means we are going to use a frequency shifting property. So we'll multiply this t value by opposite value of 4. So we are going to multiply it by -4, and this pole is will also follow the same ROC, which means we'll write inverse Laplace transform 1 by s is unit step. So this is our solution. Now in exams they will always ask you similar types of question. Most of the time they will give you, or they will tell you to find out inverse Laplace transform for 3 possible ROCs or any 2 possible ROCs or single ROC. So depends on that, you have to decide. In university exam the question will be asked like find out inverse Laplace transform given function and for possible ROCs or given ROCs. If they tell you to find out inverse Laplace transform for all possible ROCs, then then you have to consider on how many poles are given in question, and depends on that ROC marking will be decided. And if ROCs are already given, then you have to find out inverse Laplace transform of given function using given ROC. So that's all for now. We'll solve a new numerical in next video, but for that stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.